Hi, my name is Malik Muhammad Daniyal Ahmed, and in this video, I'm going to walk you through a logistic analysis I built using Excel using a data set of 500 Australian shipments. Let me start with the raw data sheet. We have 500 rows and 19 columns. Each one is a shipment. The column covers things like shipment ID, customer type, customer segments, transport mode, priority level, origin city, destination city, etc. I've also set this up as a formatted Excel table, which means we can use slicers to filter everything interactively. Let me show you that in a moment. So here I've added 3 slicers on origin city, transport mode, and delay region. If I click air from the transport mode, it's going to slice it up for all the shipments that are going by air. Similarly, if I look up for Sydney shipments, we can click on Sydney, and this is going to change and filter out all the Sydney shipments. And for the delay reasons, we can check it by weather. So it's going to filter all, and we are left with only one shipment in this. Let me clear the filters out now. Let's jump back to the next tables, the pivot tables. Uh, Here I have the pivot tables analysis on the logistics data set. The pivot table 1 shows shipment count by transport mode and priority level. The pivot table 2 talks about our average shipping cost by customer segment and type. The pivot table 3 is carrier performance summary, and the pivot table 4 is monthly shipment volume and average delivery time. All these show the date, the month, the shipment, average delivery day, and average cost. And this is really useful when you're filtering based on these monthly shipment volumes and average delivery times or other filters on the logistics data set. The next is the correlation analysis. On the correlation analysis sheet, I looked at the relationship between numerical variables, which is the distance, weight, packages, delivery time, and shipping cost. The key finding here is that distance and shipping cost have a strong positive correlation, which makes sense. Weight also contributes, but not as strongly. Delivery time shows a weaker correlation with cost, meaning longer delivery does not mean more expensive. It depends more on distance and mode. And the key findings are listed here that show relationship between distance and shipping cost. The key finding is very strong positive. Longer distances drive cost up significantly. Similarly, if we talk about base rate per kilometer, historical on-time rate, there is that is moderate positive. That's a finding. Premium carriers tend to deliver on time. Uh, and if we talk about the negatives that we were able to find through this, was the capacity pallets and workforce size. That's showing a negative value, which is a weak negative. So the larger warehouses do not proportionally staff up. Next, we have the regression model. The regression model sheet takes this further. I ran a regression with shipping cost as the depending variable and distance, weight, and delivery time as predictors. Mm, We have 3 tables here. The R squared value tells us how much a variation in cost our model explains. This is useful if we wanted to estimate shipping cost for a new route based on these factors. Next, we have the charts and visualizations. So this represents, uh, I have visualizations here showing costs, distribution by transport mode, um, monthly shipment volume trend, average shipping cost by carrier, and distance versus shipping cost. This one's the vertical bar graph. This one's a horizontal bar graph. This is a line chart, and scattered chart shows distance versus shipping cost. Next, we have the heat map and slicers. This basically is giving us color coded view of where the hotspots are, which routes or carriers have the highest score or most delays. Red means higher values, green means lower values. And the KPI dashboard is actually giving us the logistical analytics. Um, the additional analysis sheet covers the KPI dashboard uh, is showing the total shipment, on-time rate, average shipping cost, average days, return rates, and average distance. And it breaks it up into carrier historical on-time rate data bar visualization, which shows the carrier and their average on-time delivery rate. So this is really useful to understand what carriers deliver on time and what do not deliver on time. The next we have the additional analysis, and the additional analysis sheet covers a few extra things I explored, like comparing B2B versus B2C performance, looking at which weather conditions causes the most delays, and checking if express priority actually results faster deliveries. It generally does, but the difference is smaller than you might expect. So that is a full walkthrough. We went from raw data through slicers, through to charts and visualizations, to heat maps and slicers, KPI dashboards, and additional analysis, all in one Excel workbook. Thank you.